Hello again, scientists. Dr. Pumpkin here with another Science Sunday experiment. Today, we're going back to the 1970s to make a groovy lava lamp using some things that you might have at home. To make your own lava lamp, you'll need a flask or vase or similar with some cooking oil in it that you don't want to use again. A little bit of water, some food colouring, preferably 2 colours, and some effervescent aspirin tablets. Young scientists, make sure you ask the senior scientists before you borrow their aspirin tablets or their cooking oil. Right then, so our lava lamp works on 2 scientific principles: polarity and density. Watch what happens if we add a bit of water to our oil. Let's just put that in. That'll be enough. Now, let's have a look. Nope. The oil and the water have not mixed. There are bubbles of the water at the bottom. Why on earth does this happen? Well, it's because oil is something we call a non-polar substance, and water is a polar substance. Water molecules contain 2 hydrogen and 1 oxygen atom. That's why we call it H2O. And out one side of this molecule, it's giving off loads of positive electrical charge. And out the other side, loads of negative electrical charge. A bit like a magnet, so we call it polar. However, the oil molecules don't give out any charge, so it's non-polar, and the 2, they just don't mix. So if you come a bit closer, you can see that those water bubbles are still lying at the bottom of my lava lamp. And that's because water is denser than oil, so it sinks to the bottom. If we add a couple of drops of red food colouring, you'll see that they also sink to the bottom of the jar. Definitely still stuck at the bottom. Let's add a different colour of food colouring and see if that sticks at the bottom too. Right, we've got green in there as well. Yep. That's slowly sinking to the bottom as well. Okay, so if this was a real lava lamp, it would be heated from below where we plugged it in. And that would cause the denser liquid, the water, to expand and rise and create all those bubbles and those moving patterns. We can get the same effect with effervescent aspirin tablets. Let's see what happens. When you add the tablet, it reacts with the water to create carbon dioxide bubbles that stick to the water. This water is now less dense than the oil, so it rises to the top of the container. The carbon dioxide bubbles then go pop, and the water sinks back down again, and you have a lava lamp effect. And the same thing happens with the different colours of food colouring. Try it yourself, scientists, and make your very own lava lamp. And see you next time for some more amazing science.